Hi, in the previous couple of videos, we've learned how to solve first-order difference equations. When we were doing so, we were using the similarities between differential and difference equation as our guide. However, we only consider a case of a difference equation with constant coefficient and constant term. What if, like in the equation that we see over here, our term is variable? Again, we can use the similarities between differential and difference equations, and we can use the method of undetermined coefficients. And this is what we're going to do today. However, before I get into it, let me remind you one condition that we had in the context of method of the undetermined coefficients. All the derivatives of the expression we are dealing with need to be, we need to have a finite number of derivatives, hopefully going to 0. And look, the same condition applies over here. Of course, in this simple case, we know that this condition will be fulfilled. And in cases that we are actually going to be dealing with, this condition is always fulfilled. However, we will be discussing the broader concept of using this method with more complex functions once again when we will move to higher order difference equations. However, let's check if this condition is fulfilled here. Let me just remind you that we defined that difference yt is by definition equal to yt plus 1 minus yt. Okay, and what we're going to do now is to calculate difference of the function of the variable term in this difference equation. Okay, so how do we go about it? Well, we need to calculate first difference. So, t plus 1. Okay, before we actually go to using this formula, let me say that when we apply differences, we do it more or less like we apply derivatives. So, as you see over here, we've got a difference of a sum. Difference of a sum is sum of two differences. Just like in the case of derivatives, where derivative of a sum is a sum of two derivatives. So, we get that this is difference 2t plus difference 1. Again, what must be difference 1? What is the derivative of a constant? Can we have a change in a constant? No. Right away, we see that this must be equal to 0. So, all we've got to do is to differentiate this expression. And look, when we do so, we use this formula. So, first, we need to replace t with t plus 1. So this expression becomes 2t plus 1. And we subtract expression with t, which in our case is 2t. And look, out of this, we are getting that the first difference is just 2. Okay, now, we can calculate the second difference of 2t plus 1. And again, analogy with derivatives is straightforward. When you calculate second derivative, you calculate actually the first derivative of the first derivative. And this is exactly what we can do here. We can calculate derivative, first difference of a first difference. However, we already calculated this first difference. You know, it's just 2. And we also know the derivative of a constant is equal to 0, and the same as with the difference. So here we see that this condition is fulfilled. So now that we know what we can do it, let's dive straight ahead to method of undetermined coefficient. Our equation is given by yt plus 1 plus 2yt equals 2t plus 1. Okay, so if we want to solve it using method of undetermined coefficient, we need to figure out trial solution. Now, as the variable term is in the form of linear function, our trial solution, right, of the form b1t plus b0. Now look, in this context, of course, we also need to calculate yt plus 1. How do we do it? We simply substitute t plus 1 instead of t, right? So we get that this is b1 t plus 1 plus b0, right? Which is equal to b1t plus b1 plus b0. And look, now we can substitute our trial solution into the function, right? Into the equation. So we've got b1t plus b1 plus b0 plus 2 times b1t, so 2b1t plus 2b0. And this is equal to 2t plus 1. Okay, and look, I hope you know what do we need to do right now. Right? What we do next is simply we need to compare appropriate coefficients. We see that over here we can collect terms and we've got 3b1t, right? Plus a b1 plus 3b0. And it's equal to 2t plus 1. And look, we clearly see that this is a coefficient on t, so we need to compare it with this coefficient on t. This is a constant, we need to compare it with a constant. Okay, so let's start with the easier part, right? Actually, they are both very easy. We've got the 3b1 must be equal to 2. So out of this, we get the b1 must be equal to 2 over 3. Okay, very well. Now, what else do we have? We've got the b1 plus 3b0 is equal to 1. However, we already know that b1 is equal to 2 over 3. Now plus 3b0 equals to 1. Okay, so look, we get out of it that 3b that 3b0 that 3b0, right, is equal to 1 over 3. Consequently, b0 must be equal to 1 over 9. And look, but now we've got both coefficients, so we can write the particular solution, the solution that we wanted to have, and we see that this particular solution is 2 over 3t plus 1 over 9. Right? Yeah. calculations are actually correct? Well, we can substitute to our equation. So let's do so. Look, we've got yt, of course, is equal to 2 over 3t plus 1 over 9. In this case, yt plus 1 must be equal to 2 over 3 times t plus 1 plus 1 over 9, which is equal to 2 over 3t plus 2 over 3 plus 1 over 9, which gives us 2 over 3t plus 7 over 9. Okay, so now let's substitute those two into our equation, and let's make sure that what we got is actually a correct answer. Okay, so the first part, so yt plus 1 is 2 over 3t plus 7 over 9. Then plus, we need to multiply everything here by 2, right? Because we have 2 up front. So we get that this is 4 over 3t plus 2 over 9. Correct? So, adding up those two will give us 2t, and adding up those two is giving us 1. So we clearly see that our solution is correct. Okay, I know I probably discussed this to death today, so let me just explain what I definitely want from you to know. I definitely need from you to know how to use method of undetermined coefficients. So, if you see a difference equation, and on the right hand side of this difference equation, instead of a constant, we've got a linear function, we use method of undetermined coefficients. We do these two trial solutions, and based on the appropriate coefficients comparisons, we find the true values. If you don't make a stupid or silly calculational mistake, this all should work very well. And you will be able to obtain particular solution. And remember, particular solution represents equilibrium value. So again here, we are dealing with the case of moving equilibrium. Okay, now, at this moment, we've learned quite a lot about differential equations. Difference equations. Well, differentials as well. Look, that is actually the last thing I need you to know to understand everything that we're going to from this moment on. Because look, in your econometrics class, you are dealing with time series. So, GDP over time, consumption over time, investment over time, at different periods. And look, now that we know how to deal with difference equations, a lot of, on one hand, very simple, but on the other hand, very informative models of time series are becoming available to us. Because let me just tell you one thing. Look, if you have a difference equation like that, you can estimate it. You can find out what is the coefficient here, what is the coefficient here, what is the coefficient here, and what is the coefficient here. You can take this information directly from the data using tools that you learned about in your econometrics class. So, this will give us a very powerful tool. Why? Because look, once we know the coefficient of some time series we analyze, we can describe these properties based on the properties of a difference equation that we can estimate. And this is what we're gonna start doing since our next video. See you in the next video.